So reaction mechanism, basically a balanced chemical equation. It tells us the description of overall result of a chemical reaction. Alright? But what happened on a molecular level? That is represented by a single equation. It involves more steps, right? And each molecular level, what happened, it represented by each steps. And for example, reaction may take place in several steps, and this set of steps is called reaction mechanism. So it's just balance equation, it gives us just a general idea, description what happened. But at molecular level, it gives multiple steps, and those set is called reaction mechanism. Alright? Now the slowest rate is a rate determining step. So I'm going to write next one is the slowest step in reaction mechanism is called the rate determining RTD or RDS. Yeah, RDS, rate determining step. And the rate law for the RDS, rate determining step, is the rate law of the overall reaction. So we'll take an example, alright? So reaction mechanism you cannot directly observe, but you can, it's consistent with rate law. So let's take an example. So I'm going to give you an example. I think for that I'm going to go to next slide. In this one we are going to react NO2 and F2, and then we will see all the steps. So let's take an example. NO2 and F2, when it reacts, it's NO2F and F. This is a slow step. And fluorine and NO2, when they react, it's NO2F. This is a fast step. This is an example, alright? So what's the overall reaction? When you look at it, fluorine is going to cancel. So the overall reaction is 2NO2 plus F2 gives 2NO2F. This is overall reaction. Okay. So now, what is RDS? The slow step is always rate determining step. Rate determining step, right? Alright, so whenever we write rate law for this slow step, this rate law for the slow step, we can write rate equals K NO2, concentration of NO2 and concentration of F2. So that is overall reaction rate law. So this is a rate law mechanism. For this mechanism. So, what is reaction intermediate? Now remember, in this one, this chlorine cancel out, this cancel out, right? That's called reaction intermediate. It's going to produce in one step, and in second step, it's going to be used up. But in final equation, you don't see it, right? So, I'm going to define reaction intermediate. A reaction intermediate it is a species produced during a reaction that does not appear in the net equation because it reacts in a subsequent step in the mechanism. So that's called reaction intermediate. So I'm going to give you that example. Remember the previous example, fluorine, fluorine. They, in the first step, slow step, fluorine produced, and in the second step, fluorine used up. So in that one, fluorine is, in this one, you see that fluorine and fluorine, this is called intermediate, reaction intermediate. Because in one step, slow step, or any one step it produces, and in other second step it's used up.